Hey guys, welcome back to another episode of Simulators. Today's going to be an absolutely beautiful day, I'm pretty sure, because we're going to start working on the Huffman trees for real this time. Yesterday we did a whole bunch of animation stuff which will make the trees look awesome, but now we have to go through and actually do the tree stuff, and that's going to be awesome in another way. So let's go ahead and open up Zernal real quick and describe Huffman in coding, and then we'll go from there. Zernal. Okay, so just to be clear as to what we're actually going to do today, I think it's good to go through the entire algorithm because it's super short, and then explain what it is that I'm doing, because yesterday it was a little scattered, I have to admit. Okay, let's go and get started. Okay, so first of all, what is Huffman encoding? Huffman encoding is a way to shrink the total number of bits you're using for a word. The idea is, let's say you have a frequency of A, B, C, D, E's that are coming in. So you have maybe A comes in with a frequency of, let's say, 25%. B comes in with a frequency of 25%. C comes in with a frequency of 25%. D and E come in with a frequency of, let's say, 13% and 12%. Okay? These are all with dot, 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 dot. Okay, these guys add up together to be 25. These guys add up together to be 25. These guys add up together to be 25. These guys, I'm sorry, 50. 50. And then these guys add up together finally to be 100. Okay, so now you do 1, 0, 1, 0, 1, 0, 1, 0. And you get A as 1, 1, B as 1, 0, C as 0, 1, D as 0, 0, 1, and E, one second, sorry it's so small there at the bottom, as 0, 0, 0. And this way you have an ideal formation of bits to encode A with. You also have a tree to decode everything with. So it turns out pretty well and works pretty okay. Page, new page before. So what we've got right now is we have the ability to create Huffman trees. We also have the ability to decode and encode Huffman trees, and that's fantastic. So today what we're going to do is draw the Huffman tree. One second. Okay, so what does this mean? Well, let's say we have A, B, C, D, like we did in the previous example. This simply means we have to put them in the appropriate location, and also, sorry about that, and also connect them with interior nodes as they're supposed to be connected. I don't know how these guys are supposed to connect, but I can tell you that's probably not right. Anyway, so the idea is pretty simple. We just have to connect all of them together with interior nodes, which will not have dots on them, and then have exterior nodes, leaves, have leaves on them. Now I know that was like a quick 2-minute introduction, but quite frankly that's all we need to know for this particular simulation. It's Huffman encoding, right? So Huffman encoding is really cool, but at this point not particularly interesting yet. We're going to do something really cool in the future with them when we introduce dynamic Huffman encoding, which will be done in, I don't know, a week or something like that. Hopefully I'll be looking into it today a little bit more detail, and that'll get me through the next 2 videos actually on Laos OS. So we should do one video on Huffman encoding and then another video on dynamic Huffman encoding. I don't know if they'll be back to back, but they'll be pretty close. We still have to do a video on diagonalization, molecular dynamics, a whole bunch of stuff like that. So I'll see what you guys want to do, but since you guys voted for Huffman encoding last time, I think I'm just going to try to get this video out as soon as possible, hopefully for the next video on my channel. And we'll see how far that goes. Now again guys, there isn't very much left to talk about, so if you have any specific questions let me know, but we have everything else kind of set and done for this particular simulation. We have the Huffman tree encoded, we have the encoding and decoding working, and I'll show you that in a second. So I think we're good to just go ahead and get started with the visualization, and we'll see how far we get. If I can get one version, the simple version of the visualization done, then we can move on to the more complex version, in which things are going to be a little bit different, but I think they're going to look really good. Sorry for the yawn, guys. Okay, so let's go ahead and get started. Okay. So let's pop this over there, and let's CD into projects. 1 second, projects, Simuleos, and of course we want to do Huffman. ls. Let me just show you guys what is currently working. So if we run a.out, you'll see that we have just a simple encoding scheme, and then we have an encoded phrase. Then we have a much more complicated encoding phrase, where the phrase says, Jack and Jill went up the hill to fetch a pail of water. Jack fell down and broke his crown. Jill came tumbling after. New line, woo. We have an encoded phrase, and the decoded phrase is exactly what we want. Jack and Jill went up the hill to fetch a pail of water. Jack fell down, broke his crown, and Jill came tumbling after. So we can do encoding, we can do decoding. Everything seems fine. This is exactly what I want to see. Now, what did we do yesterday? Well, yesterday we did the following. I think it's going to be under frames, animation.gif. Okay. Now I know it doesn't look like much. Let's move this over here. I know it doesn't look like much at all, but I'm quite happy with this. We can create dots, we can create lines. So I guess now it's a matter of drawing everything together. So of course I chose green because Huffman trees, right? So trees are green, and white just because white looks good on black. So hopefully this will end up looking pretty dang good when we get everything done. Let's go ahead and open up the visualization. So vi Huffman, oh sorry, we have to CD into the appropriate directory for CD projects, Simuleos, Huffman, and then ls, vi Huffman, visualization, that's CPP. Okay, so we are here. Now we have to do a number of things. So what do we need to do? Let's see, we have a position for each of the external and internal points, right? And we basically need to create some sort of, how do I put this? Some sort of vector of all of the points we need to plot. So, and what they're connected to. Now we already have the primary node, right? So basically all we need to do is draw a couple points, connect a couple points, draw a few more points, connect a few more points. So what we need to do is draw all the leaves first, all of the exterior nodes. And then we need to draw all the interior nodes in the appropriate order. And that's going to be a hard task. But we'll see if we can get it done today. If we can, I'm going to be super excited. This is going to be absolutely awesome. Okay, first things first, I need a quick sip of water. And then we can get started with the programming and we'll see what we need to do. Thanks again for watching, and give me just a second. Okay, good to go. One last note before we get started. I spent the entire day yesterday editing my new YouTube video, which turned out, I think, very well. It, in some ways, maybe is not as visually appealing as my previous video, but hey, you know, it's Monte Carlo. It's super cool. We'll see what happens when I upload it in a few hours after the end of this stream. So I should upload it at 9 o'clock a.m. Japanese Standard Time, which will be 7 o'clock p.m. In the US, and honestly I don't know, it might be a little bit late for you guys in Europe, maybe midnight or 1 o'clock, so I understand if you guys don't see it immediately, but that's that. So the video will be up at 9 o'clock in a few hours after this episode. So one thing I have to do, or a couple things I have to do, I have to add annotations to the videos on YouTube, and then I also need to create a blog post on my website, leos.github.io, about basically integrating the Batman symbol, and then that's going to be it. Let me go on my stream real quick just to make sure. Okay, good. So let's go ahead and get started. What do we need? Well, we're going to need a function, and this function needs to return a couple of different things. So let's go here and let's just create it as void, and we'll decide what we actually needed in a second. So it's going to be function to draw Huffman tree. Okay, so what do we want? We want void draw tree, and what do we need to read in it? Well, we have some stuff that we can read in it already. Let's go ahead and write and quit. Let's go into huffman.cpp. Okay, so it looks like we have oh sorry, I should have gone into huffman.h, my apologies. H. Okay, so it looks like we have a couple of different structs here. The one that I want is Huffman tree. It's got root, unordered map, and encoded phrase. Okay, so here's what we're going to do. We're going to say, 1 second, Huffman visualization.cpp, G. Oh, sorry. Let me scroll down. Draw tree, and we want Huffman tree. And what are we going to call it? I guess we'll call it just something super simple. Tree. Okay, there we go. We got that. Okay, so let's go here. And let's put it down at the bottom here. Okay, so we have the draw tree function ready to go. So we're going to have to do something a little bit weird. Okay, so we have to draw from the leaves first, the exterior nodes first. And we also know the length of each exterior node's string, right? Now, the length of the string should somehow be related to what do I put here? Should somehow be related to the distance from the central node it's at. So the first thing we need to do is determine the distance from which what do I say? Determine the distance from which each character is, okay? And then we need to kind of put it into place. So we have the node itself. Let me see, the root node, which has connections to everything. And then we need to kind of create this, how do I put it? I mean, we have to create the tree, right? So we'll go from there. Okay, so we're going to say we want a vector of positions, where position is defined up here as having X and Y. And then we want this to be of, let's say, external nodes. Okay, so this one's not so bad. Okay, so what do we need to do? Let's go through and say creating positions for external nodes. Guys, forgive me if today is a little bit off. Again, I didn't have very much time to prepare because I was spending the entire day yesterday editing my YouTube video. So forgive me again if it's a little bit slow. Okay, so let's go ahead and do for int I equals 0, I less than, let's say, oh, actually, I don't know how much less than this is supposed to be. So we have the a map. So let's do this. Let's go through the entire map. We're going to say for auto key in bitmap, I believe is what I called it. Then we just go through all of those and we say up here, let's define an integer, which is the max value. Max characters, or max bits, I guess. Yeah, that'll be it. Equals 0. And we'll just go through and do this in the simplest way possible. Now we could search for the maximum. This is fine. This is fine for now. We're gonna say max bit is going to be equal to, rather, if what is it gonna be? Auto, so key dot second dot size is greater than max bit. We don't have so many elements, so this is okay. Then we say max bit is going to be equal to key dot second dot size. And one thing that we need to do is obviously create our tree before getting started. So let's do that too. Let me go up to the main. And let's just go ahead and put in our tree. So we have this draw frames guy. That's fine to leave that here for now. And let's go through and let's create our tree. So tree from Huffman.cpp. Let's write this and let's go ahead and open it up over here. So let's go into vi Huffman.cpp. And let's follow what they have in main. So it looks like here's what we want. Huffman tree final. Wait 1 second. This is what I want. Encoding with 2-pass Huffman here. Okay? So this will give us a final tree to work with, and then we can go from there. Now, one thing to note, because I'm using VI here, let's go ahead. I should probably have used a less complicated phrase, but that's okay. And done. Okay, so now we have our final tree. Let's go there and delete this line. Okay, so that's the final tree we had before. So if we run this code after drawing all the frames, we should see it output all of this encoding stuff. And that's good. So now we have the final tree. Let's go here and let's say, what do I want to do? I want to do draw tree of final tree. Okay, let's go down to the bottom. Let's go and write this. Now let's go over here and let's control C. Oh, why did I control C? That doesn't make any sense. Run quit. VI the make file. And let's not animate anything because there's not going to be anything to animate. And let me go up here and not draw the frames, because at this point I don't think it's particularly necessary. So let's go ahead and just comment this entire guy out and this guy out. Write this, write quit, make. Okay, so it looks like we have a whole bunch of problems, which is fair enough. So we're going to go to vector. Of course, we need an STD before that. Okay, next, max bit. Let me see. Vector position, external nodes was not declared in this scope. Was it not? Oh, no, yes, it was. Okay, let's go here. Let's make. It's going to give us one more problem, and that is bitmap. So we need to do tree.bitmap. Now we're going to go down here and output the maximum bit. Max bit end line. Oh, that was meant to be a semicolon. Semicolon. Now let's go over here and let's make key second size. Oh, okay, that's fair enough. I forgot some parentheses. Make it. Let me see. Comparison between signed and unsigned integer in expressions. Let me see. Undefined reference. 2-pass Huffman. Let me see. I'm not sure what's wrong here. Oh, I guess. Weird. Okay, so let's go into right quit. Let's go into Huffman.h, and we should see no Q decode. Yeah, decode should be in there. Right quit. Let's go into the make file real quick. And let's do this. Let's do Huffman.o and then Huffman visualization.o. Make. Okay. So we're having a bit of a problem here. Let me see what we have. Undefined reference at 105 of Huffman visualization.cpp. Okay, so we clearly, let me see. Undefined reference to decode. Okay. So we're having trouble using the stuff from our Huffman.h file. Sorry about that. Yeah, that's fine. That's not the warning I'm talking about. I'm talking about the warning down here. The signed and unsigned integer is not going to be too big of a problem. Thanks, senior publicity. Okay, so let me do this real quick. We are including Huffman.h. Huffman.h should have everything we need inside of it. Let's see. Let's go down here to the bottom. All right, what am I doing that's stupid here? I'm not really sure. We have Huffman tree, 2-pass Huffman, and void decode. So everything should be working okay here. Let me see. I mean, besides this, but that's okay because that's just a warning. Okay. Returning status 1. Oh, this is a linker error. Okay, so let me go into the make file. And let's see. It looks like bins.cpp, Huffman, visualization. Yeah, so it looks like we're having a problem at the very end there with some sort of linking error. And I'm not exactly sure what the deal is there. So let's go ahead, run quit, make clean, and let me try making it one more time. Okay, I didn't figure that would help. But this is an issue with our makefile, which is fine because I'm really bad at doing makefiles, but I thought we had this fixed. Okay, so let me see. Huffman visualization 105, undefined reference to toPass. Let me see, undefined reference to decode. Let me do LD returned 1 exit status. Maybe this is something that people have seen before. So let's go here. Let's pop this here and see what people say. So compile error exit 1. See what they say. Your problem is typo with the function. You should change it to create dictionary. Well, that's not what I need. Plus you have a typo in dict.c. Create dictionary. Nope, that's not what I need at all. That's a misspelling. Let me see. What do we have here? Include program GCC. Hope this would help. Nope, that doesn't help me at all. Okay. So, decode toPass Huffman. Oh, you know what? Let's go into our Huffman.h file, or Huffman.cpp. Let's go and comment out main real quick. Just so there's no ambiguity here. I don't think there will be, but just in case. Make. Yeah, I didn't figure that was the issue. Okay, so I'm actually not sure what the issue is here. If you guys want to help, feel free to go under my channel. Oh gosh, we have like no one here today. Feel free to go under my channel, github.com, and let's see, Simuleos. Where are we? Huffman. And this is what we're working on right here. So feel free to help me out if you want. But basically we need to get that makefile working. Okay, so what do we need to do? Well, let's take a look at the makefile. Okay, so we have G++, CXX flags of SD C++11. All that should be fine. Cairo flags, bins, objects. This should be fine. I'm actually super confused because it works. It worked when we didn't link the stuff, right? So let's see. Dependencies, which is going to be Huffman visualization or Huffman.h. We compile it into an object file. Let me go back over here and let's just do what we did before. Nope. And let's look for makefile. Okay, let's see what we got. Add C to the rules building object files. Without this, the compiler assumes you're creating executables. No, but I think we have a C, don't we? Yeah, we do. Okay. Let's see. Statwrapper.o, tools.o. Let's see. Sweeper.cpp. Let's see. This is like a super standard makefile too. Returned. Let me see. These guys aren't helping that much either. Okay. If so, wait, did no one answer this question? Dang it. Exit 1 status. Okay, so let's go through and let's see if we can figure this out. Okay, we have all these dependencies. Well, we only have one dependency, which is Huffman.h. And then we have the bin, which is Huffman visualization. Now we have it dependent on all the objects, which is Huffman.o and Huffman visualization.o. Then we have, let's see, CXX flags, Cairo flags. All that should be okay. Bins.cpp. Let's just build these guys manually, because at this point it's probably not worth it. Okay, let's comment that guy out, comment this guy out. And the big guy that we need is Huffman.o. So let's do Huffman.o. And we're going to build it with Huffman Huffman.cpp and Huffman.h. Elgas, what do you mean that's my IDE? I'm not using an IDE. Then we do Huffman.h. Okay, next we go down here and we say CXX, basically the exact same guy that we had before, so CXX, CXX flags. Then we do Cairo flags. Actually, we don't need Cairo flags with this one. We might just be able to do this. So C, output, and again, I'm gonna kind of do it this way. So we're gonna say Huffman.cpp. Then we do -o. And then what do we want for -o? We want Huffman.o. Okay, and let's go ahead and try this. So we want this, and what do we want? What did I just remove? I removed Huffman visualization. Let me go ahead. See, so I removed bins. No, I removed dependency. So we want Huffman.h. And then we also want... No, maybe that's it. Let's go ahead and make. Make clean. Make. That didn't work. I guess it's because we need to put this guy up top. So let's move this down underneath the bins. And let me see what kind of error that it gives us. Make. Missing separated between tabs. Yes, I sure did. Okay. Make. Okay, so it says the same problem we had before. Undefined reference to 2-pass Huffman. Okay, so this is kind of a pain in the butt. Let me go to here. And let's just say Huffman.o. Make. Okay, dang it. So I hate freaking make files. I thought it worked, and it doesn't work. We were supposed to get a whole bunch done today, and now we can't get anything done because of the freaking make file. That's okay though. Again, if you guys want to help, feel free to let me know. The file is available on the link that I just posted in the chat. Of course, we have for some reason, very few people here today, and I'm not sure why. So if there's something wrong with the stream, let me know, because I can totally fix that as soon as I see it in chat. Okay, so let's go here. That was kind of a waste of time because it didn't really do anything. So let's see, Huffman.cpp, Huffman.o. We are creating Huffman.o. Let me go into another make file that I use all the time. Maybe this will help out. So let me go into that, and let's see what we got. So, 1 second. Okay. Let me go into source. Oh no, I think it was in make, just right here. There we are. Okay, so we're making GPUE and we need all these .o files. Yeah, that's exactly what we need. Okay, so then we CC. Let me see, what do we have here? CXX O bins, bins.cpp. Let me see. Bins is going to be Huffman visualization. So we want to do that. Huffman visualization. Then what do we want? We want Huffman visualization.cpp. However, let me see. I guess we also need the object files, right? So what if I just do Huffman.o? Make. Okay, good. Now that works. So let's go into the make file and let's update this one more time. So let's go ahead and comment these guys back in. Comment these guys out. And then we do the following. Change this to, what do I want? Objects. OBJ. And then change this to what we want here. So we want, let's see, Huffman visualization. So this is just going to be bins. And this, of course, is going to be bins. 1 second. And then this right here is going to be objects. So let's see. I guess I could do this in a kind of fancy way. Let me see. How do I do that? I want what is on the... Yeah, so is it going to be this guy? Make. And it was. Good. Okay. So just for the record, in case you're not familiar, what I just did is I put in a $ and a less than symbol. And what this does is it takes the object that is here. So with makefiles, you have two different symbols that are kind of useful to know about. One is $@, which takes whatever is to the left, and the other is $less than, which takes whatever is to the right. And so that's kind of the way it works there. So let's go ahead, DD, and let's go ahead, right and quit. Let's put up the animation again. So let's do Mirage, frames, animation.gif. Okay, so this is what we want to do, right? We want to create basically a position for each of these green nodes to appear, and then we want to visualize each of those nodes. So what we need to do then is we need to go through and create basically a position for each of these nodes to appear in. Now in the Huffman visualization code, let me go ahead and right and quit. Huffman visualization.cpp. Let's go down to main and let's show what we have so far. Right now we have a couple positions, ORI X, ORI Y, ORI 2X, ORI 2Y, and these are the origin for each of those dots. Then we grow each circle and we animate the lines. Now one line we went back in time for to animate, and I'm very happy to say that that worked out very well. So now we have our tree and we're drawing the tree. Let's go down here. What I just did is I went through in a very super simplistic way to find the maximum bit size, which is going to be basically the size at which we, how do I put this? It's going to determine the x-axis, how far on the x-axis we need to go. Hey, I care, thanks for coming in. Okay, so let's go through and now let's determine y positions. So determining y positions. Okay, so now that we have the max number of bits, let's go through and basically do the same thing we did before. So now we just go through every single one of these guys, and we provide for it a maximum, or rather provide for it, yeah, the appropriate position. So let's go through here and let's say for auto, and there's more elegant ways to do this, I get that. Tree dot bitmap. Okay, and let me just make sure it ran just a second ago, and it did. We have a maximum length of 7. Is that true? Let's see, 1 2 3 4 5 6 7. It looks like that's true. Good. Okay, so now we're going to go through each of them and we're going to find an appropriate y position. So what I need to do, how do I find the length of a map? Size of unordered map. Unordered map size. Can I do that? Let me see. Size type. Does it work? It looks like it works. Let's see what happens. Okay, so now what we need to do is go through each of the characters here and give them all an appropriate position. So let's go through and determine X and Y positions at the same time. X and Y. So the way I'm going to do this for now, because I think this is the easiest way to do it, is I'm going to say the number of ones, we're going to add in the number of ones and the number of zeros. We're just going to add them up together. Ones will make you go, I guess, left. Zeros will make you go right. And we'll see what happens. So we basically need to start at some position and go from there. So let's go here and let's create std. Oh, we already have that. External nodes. So let's say external nodes is going to be of size. Oh. I guess we're going to have to do this kind of in an inefficient way. And that's okay. So we're going to say, 1 second. Position, I'm sorry, what am I doing? Oh no, that's right. Position, temp, position. That'll do. Now we say temp position dot y. What do we do? Temp position dot y is going to be equal to basically, what do we want here? We are going to multiply. Okay, so let's go up here, and when we draw the tree, let's read in a resolution in X. So we're going to say position, resolution, and then we're going to read in that resolution. Let's go up to the top where we define Huffman tree. Let's do draw tree there, and we should use it in main. Okay, good. So creating resolution, and what do we want? We want let's say position resolution, and then we're going to say resolution dot x is going to be equal to, I think it's 400. Oh, how about we just do it this way? Anim dot resolution x, and then we're going to go down here. We're going to say resolution y equals anim dot resolution y. Okay, now we're going to go down here and read in resolution, and of course we have to go up once more to draw tree here and add in position resolution. Go down to the bottom and let's get started. So temp position y. What are we going to do? We're basically going to say it's equal to key dot second dot size divided by max bit. Okay, and we want this to be a double actually this time. Good. Key second size should also be a double. Okay, and then we're going to multiply this term by the resolution y. And that's going to be our y position. Now for our x position. To do this one, we have to kind of add up the total number of ones in a string. So let me see if there's an easy way to do this. Add up total number of ones in bit string. Okay, so let's see. Total number of ones in bit string. Or in string. Maybe that'll help. Techniques for adding numbers 1 to 100. Let me see. Nope. Okay, let's just do it our own way. So we're going to create a function down here. We're going to say find x position. Why not? So we're going to say we want to return back a double. It has to be find x position. We're just going to do it this way for now. It's okay. So what we need to read in is the resolution. And we also need to read in, let's see, the std string. So we want std string, bit string. And then we want also, let's see, resolution. Oh, position, resolution. Okay. Let me go ahead and create this up top. Let me add in a quick comment. Creating, or rather, finding x position for, let's see, what do I want? Finding x position for Huffman tree drawing. Okay. So let's add this up top and let's go from there. 1. Okay, now let's pop down to the bottom of these guys here. And we might put this in the actual function itself. I haven't decided yet. I don't like find x position. I just don't like, let's say, it's okay. We'll leave it. Okay. For int I equals 0. Then we're going to do I less than bitstring.size. 1 second. Dot size. Then we're going to do plus plus I. Okay, now we're going to say we basically add up the number of zeros if, and let's go up here and say double, what do I want? X position, I suppose. Hamming weight. Open link. This is fine. Let me see Hamming weight. C++. If there's an easy way to do it, that's fine. Yeah, so they're doing basically the same thing that we got to do, I think. Unless I'm missing something. 1 second. Optimization Hamming weight for vector of integers. Yeah, so it looks like they're doing just about the same thing. Yeah. Okay, that's okay. We will kind of stick with this. So what do we need to do? If, what do we want? Bit string. Wow, missed that one up. Bit string of I equals, let's do 0. Then we do the following. std cout, let's say found a 0. End line. And we're going to say exposition is going to be, what do we want? Exposition minus equals exposition minus 1. We have to define exposition as 0 here. And now let's go down here and say if bit string, wow, I cannot spell, string of I equals 1, then we add 1. Std cout found a 1. Good. End line. Now we go down here and we say exposition equals exposition plus 1. One thing we need to read in is the max number of bits. So let's go here and read in int max bit. Now we're going to go down here and say exposition. Let's do position. Divided equals by the double of max bit. Okay, and then we have to multiply this. Let me see. We have to multiply this by, here, let's do it this way. X is going to be equal to exposition divided by double max bit. Then we have to multiply this by the resolution in X. Okay, that looks good to me. I think that should be okay. So now we're going to go up here and say temp position X. Position X is going to be equal to this guy down here. So find X position with, let's see, we want tree dot bitmap dot second. Then we want max bit, and finally the resolution. Now we're going to go down here and we're going to say, let me see, external nodes dot pushback. What do I want? I want temp position. Okay, so I don't know if this is going to compile. Actually, I know for a fact it's not going to compile right now. I need to add an int max bit. So let me go up to the top. And let's go down to find X. And let's add an int max bit. Int max bit. Okay, let's go ahead and write this. And let's see what it looks like. So let's make it real quick. Okay, and let's see what we got. Rex X. That's a problem. 348. And did I forget to return? I totally did. Totally forgot to return. Return X position. Make. Okay, so what happened here? We have template argument. Let me see. SE basic OS stream character not derived from is stream found a 1. Oh. The alligators need to eat things the other way. Make. Okay, now we got a whole bunch of errors that we can fix. Let me see. Anim was not declared in this scope. Let me go to 113. Are you sure? I didn't define anim? Oh, no, I didn't. Dagnabbit. Okay, what's next? Void, draw tree. That's fine. That's just a comparison between signed and unsigned. Has no member named second. Tree.bitmap. That's fair enough because it should be key.second. So 327. So this should be key.second size. Ah, here it is. Key.second. And what else do we have? ISO forbids comparison between pointer and integer. Let me go ahead and make this one more time. Well, let me write it first, and now let me make it. Okay, so we still have a couple of different things here. Comparison between signed and unsigned integer. That's okay. Let's go ahead and fix that one right now. 338. So this needs to be a size T. Okay, let's see. Comparison between signed and unsigned integer here. 330, 317. Let me see. So the problem is max bit. Yeah, this is always going to be positive, so we can set this to size T. Okay, next, comparison between string literal, okay, so let's go here, and let's change this to, 1 second. I had this problem before, and I don't remember how I fixed it. Let's go here, make. Okay, there we go. We're finding a whole bunch of ones and zeros, which is great. That's exactly what I wanted to see. So let's go ahead and comment these lines out, because I'm now confident in saying that we are officially working with this, finding an appropriate position. So now we have all the appropriate positions. Now we just need to draw points at each of those positions. So I guess let's go through and do that. So what do we need to do? Let's go up. We have, I think, 30 frames. Yeah, 30 frames. So I guess we have the number of frames, right? Let's go here to draw tree, and let's add in one more thing that we need, which is going to be frame anim. Okay, let's go up to the top and add that to the draw tree command. Where are we? Here we are, frame anim. Okay, now we go down to draw tree itself. 1 second. We do anim. And then one last thing we need to do is anim.drawFrames. Okay, so now we should have, oh, oops. I screwed up the notation there. Okay, now we should have all of the appropriate X and Y positions, right? So let's go through and let's just do it. So let's draw them all. Yeah, let's do it. So we're gonna say 4. Let's do size T, I equals 0, I less than, what do we want here? We're gonna want external nodes dot size. Then we're gonna do I plus plus or plus plus I, doesn't really matter. Let's go down here. Borox 148. What do you think of game programming? I do not do game programming. It's not something that it's not that I wouldn't enjoy it, because I have done game programming before and it's kind of enjoyable. It's just the problems are different, you know? So for example, game programming, you're worried about the end user. You're worried about him or her being incredibly happy with your results. So in the end, a lot of game programming isn't so much the programming, the technical aspect of it. It's making it presentable, making it good, making it glitch free, making it work, you know? And also making it absolutely stunning and gorgeous. So a lot of game programming has to do with art decisions and things like that, which I personally am very bad at. So it's not really my cup of tea because of that. I'm not very good at making things visually appealing, unless I like understand it on an intuitive level or something like that. It's also not my problem to solve. A lot of other people really enjoy game programming, and I love the fact that they enjoy game programming because it's created a whole bunch of really cool games for people to play. But at the same time, I don't play that many games, you know? So for me to do game programming, sure, I might enjoy the game programming more than playing the game itself, but I wouldn't know what people want, and I wouldn't know what would make a good game. For me, a terminal-based, I made, at one point at a hackathon, a terminal-based academia-themed card game. It was absolutely awesome, but, you know, no one's going to play it because it's terminal-based. Apparently people care about graphics or something. I don't know. But yeah, so my idea about game programming is that it's fine. People do it. I do not do it, especially not on this channel. Now, visualization is a different thing, and it is something that we will do on this channel, which is what we're doing right now. I hope that answered your question, and I apologize if I did not mean at all to seem dismissive of game programming, because that's not what I am. I honestly think that people who do game programming are absolutely great. It's just, it's not my cup of tea. And I can say that my cousin, for example, really wants to be a game developer, and that's fine. I think that's a perfect job for him to do, but it's just, again, not for me. Okay, so let's go here. It's kind of like web programming. It's not for me either. So we got all these external nodes. Now let's go through and let's draw them out. Hey, Merplix, how are you? What is this? We are drawing a Huffman tree. If you wait just a minute, we're going to draw all the external nodes, and then we have to worry about drawing the internal nodes next, which is going to be a little bit more difficult, but that's okay. We're kind of getting started one step at a time. So we have all the appropriate Y positions here. Now let me see, did I get those in the appropriate position? I think so. Let's just draw it and see what happens. Okay, so we have this function that we created, which was grow circle. What do we have? Where was grow circle? Grow circle was right here. So we have frame and anim, time, position ori, and double radius. I guess we're good to go. So what did I put in for the previous radius? 10, I believe? Good. We'll do the same thing here. Let's go here. Pop it down to the bottom. And let's do it. Okay, we're going to put this down here. And then we're just going to anim. Needs to be read in. Double time. What do we want for time? Time is going to be, let's see, we have 30 frames, right? The FPS is 10 frames per second. So we want it to be, let's see, 30 frames per second. 10, it's a total of 3 seconds. 1, 2, 3. Yeah, 10 seconds sounds about right. So let's go ahead and do 10 seconds divided by double of external nodes dot size. Okay, this one, sure. Let me go here. This is, yeah, it's for data compression. It's basically for, well, okay, so this channel, right, is based around doing somewhat complicated, let's say somewhat complicated algorithms of some sort. Usually they're physics algorithms. This one is more or less a computer science algorithm. There isn't very much physics here. But that said, we're going to be moving on to, what is it, the dynamic Huffman encoding, which is the Vitter algorithm in a bit, in the next few days, I think. And so what we want to do is have a very good visualization scheme so that when we do the Vitter algorithm, it makes good, it makes sense, you know? And the other thing too is that this will later be put onto my YouTube channel where I describe how to do Huffman encoding and things like that. So I'd really like for this to make a good amount of sense and look pretty cool, you know? And so I kind of want to make this look as cool as possible, while also maintaining the ability to show people what is actually going on underneath. So there's a good bit of stuff here. Honestly though, because it's over the weekend, most of my weekend stuff is just kind of playing around and drawing with code, not necessarily doing algorithms and things like that, which is done during the week. So we kind of trade off between working on the algorithm itself and working on visualization of the algorithm and stuff like that. And again, the visualization is put on my YouTube channel later, which is LeosOS. There's a link in the description. I can give you guys a link if you need. Okay, so next we need the actual position, which is going to be external nodes of I. Now I could have done this a different way, that's fine. And let's go here and change this to 10. Okay, so now let's see what happens. Well, good, I'm glad you like it. Okay, so now we grow all the circles, and let's see what happens if we just... Yeah, let's see what happens if we do this. So let's go here. One thing I forgot to do is I forgot to give anim up here an ampersand, which is kind of a big deal in this case. So let's go to draw tree again. Draw tree. Draw tree. Here we are here. And we're going to add in an ampersand here. Since I need to compress my packets for the netcode. I wish I could help more, but this is really super simple. Hey, Witty Bants, thanks for coming in. Let's go ahead and write this. Go over here, and let's make it. Okay, let's see what happens. We seem to draw something, so let's take a look at what we drew. We're gonna do animation.gif. Oh. Oh. My bad. Let me go into the makefile one more time. Okay, so what do we have here? Makefile is there. Let's go ahead and remove this. And now let's make it one more time. Oh, sorry, make clean. Make. Okay, let's see what we drew. I'm not actually sure what it is that we drew. Hopefully it looks okay. Let's do Mirage. Oh, what? Huh. It's not quite right. Let me think. So we have 300 by 400. 1 second. I think I see the problem. What we need to do when we give these guys an initial position is we need to subtract out the origin that we're currently at. So let's go here and let's see what we got. So here, I'll leave the animation up in case you guys have questions. But see how we're just basically appearing, things are being created here, and they're kind of going off the screen. That's because the X position, as it's currently set, allows it to go off the screen. However, the Y position seems okay. Why isn't it hard coding without different colors or bracket indications? Let me see. Isn't it hard coding without different colors or bracket indications? Oh, you mean the text editor? No, I don't like those. They kind of drive me nuts, actually. I've been using VI for so long, like the past 5-6 years, that coding with them actually feels like, I don't know, it feels wrong to me, you know? And that's basically it. Yeah, marrying, basically, by the way, Marion G, I just looked up, I just went to Twitch, and the G is actually capitalized in your name. So I apologize for calling you marrying at all this time. I can call you Marion G from now on. I apologize for that. The IRSSI automatically uncapitalizes everything, so I apologize for that one. Anyway, let's keep going from here. What do I want? This X position, I need to read in one more thing to the find X position, and that's going to be anim. So let's go here and say frame anim. And for the record, let's just put in Marion is fine too. Okay, so let's go here. Let me go up to the top to find X position. X position. So here we are there, and here. Let's read in frame anim. Oh, come on. Anim. Okay, now what we're going to do is N, and read in anim here. Okay, so now when we have this, we're going to say X position minus 1, X position plus 1. This is going to be plus times resolution X, and then we're going to add in, at the very end here, it should be, oh, we're already reading in the resolution. I'm an idiot. Plus resolution dot x, 0.5 times resolution dot x, 0.5 times. And let's remove frame anim from all of these guys because now I realized I'm an idiot and we don't need it. That's okay though. It's better to realize I'm an idiot now than later. That's the way I see it anyway. Okay. I think if I press N, yep, good. N. According to the stream times, if I've calculated it right as in my time zones, does the stream end in 3 minutes? No, it ends in 1 hour and 3 minutes. It is, I don't know if you can see it, but there's a clock down here in the lower left-hand corner, and that's 6 o'clock a.m. my time. So, plenty of time. So, let's go here and let's go ahead and write. Let's see what happens if we make this one. Wait, we subtracted. Should we add? I think we should add. Oh, we did add. Good. Okay, let's go here and let's do make. Okay, let's see where they appear. I've got a feeling this is just as bad as the last one. So let's go here and let's do mirage animation.gif. Oh, look at that, guys. It almost looks like we're creating a tree. Yeah. I don't know. Huh. Huh. Oh, so you must be in the US then. Or not the US, the EU, or somewhere in that area. Maybe the UK or something. I hate AM PM, so really annoying. What I would like, X Salvinger, lower right or lower left? Lower right. I think I said lower left. My bad. I always get right and left confused. I don't know if you guys ever have this problem, but like, people will say, it's what you need to do to figure out right from left is look at your hands and whichever one makes an L, you know, you use that one. But then the problem is, like, if you hold this hand this way, it makes an L, and this one this way, it doesn't make an L, and then I can never remember which direction the L goes, so I usually just designate left and right based on whichever one has my watch, which is currently off, so I can't tell right from left at this point. Okay, let me go through and let's fix this up. So the dots are appearing, and they're appearing at different X and Y locations, so this is good. But I'm not sure I don't know if I understand. Let's just draw the internal nodes and see what it looks like. Okay, so let's go up here. And when we initially create the resolution X and Y for the draw tree command, let's go through and set the resolution to be slightly smaller than the resolution of the actual screen. So we're going to do main, and let's go here. So the resolution of the actual screen is 300 by 400. What I want to do is I want to do resolution X, and then I want to subtract out 50. And then we're going to go here and subtract out 50. Okay, so this will give us resolution X, resolution Y. Wait, what will this give us? I've got a feeling this isn't going to solve our problem. Let's go to make. Mirage animation.gif. Well, it did solve our problem, but I'm trying to think here. Oh, fair enough, Marion. Okay, so what are we going to do? Animation. We can... Fine. Okay, here's what I'm going to do. I hate doing this, but fine. We're going to go to draw tree. And what we're going to do is we are going to remove the resolution here, and we're going to add in frame anim on top. Okay, and we're going to go down here, and we're going to add anim. That way we don't need this resolution. Okay, and here we'll be good to go. Final tree. What am I missing? Draw tree, frame anim. I was already reading in anim? I'm sorry, guys. I'm screwing up big time, but that's okay. Oh, Tsunehito. Hey. Let's go here. And let's do frame anim. Good. Okay. I like this music. I know some people don't, but I really like this music. It's pretty good. I hand selected it from Woodward's stuff, and then I sped it up by 150, so it's fast enough for stream. It's great. I don't know. It's one of those things that I just really like. Anyway, let's go down and let's see what we got. Draw tree. Good. So let's go down to find X position. And let's modify this one to position resolution. Let's go here and let's do, what do I want? Frame. Anim. Good. Instead of resolution X, what we're going to do here is we're going to say, anim.resolution X. And of course here, anim resolution X. So you've been working on these animations, imaging stuff for a few days. What is it actually all about? The animation stuff I just started working on yesterday. However, animation for the Monte Carlo algorithm I did as of last week. The idea is that I want to make this stuff visually appealing because now, okay, so let me kind of take a step back. Twitch for me is a great outlet for doing programming, right? But I also have a YouTube channel, and the YouTube channel is where I post kind of, yeah, sure. So a while ago, okay, here's the thing. It's actually changed a little bit, Marion, since the last time you saw it, but we actually spent a while visualizing Monte Carlo. So let's do a second. Let's go back to, I think it's Monte Carlo. No, it's visualization, Monte Carlo, and let me ls. Good. So now let me run, where did I put it? One second. Bat blocks? What is anim1.gif? Let me do Mirage anim1.gif. Okay, so we did basically a simple Monte Carlo algorithm, right? So this is this is this guy, right? This is actually going to be in my YouTube video, which will be out later. But we also did the Batman symbol, which I don't remember where I put it. So let me do mplayer. I think it's going to be here. So let's do storage. Where is it going to be? Storage, videos, MC1, batman.mp4, vo x11. And I'm also going to run loop 0, just so it loops. Yeah, so we also did the Batman symbol, which I think looks really good. I'm pretty excited with how this one turned out. Again, it's going to be on my next YouTube video, which is going to be out in like 2 hours after the end of stream. But I'm super excited with this one. So this was one of the visualizations we've done with this stuff, so with Cairo and stuff. We're now working on our next visualization, which will be of Huffman trees, which should look amazing. This is one I'm actually super excited to do, the one with Huffman trees. But yeah, so we've been working on these visualizations for a while because in some sense it makes sense to do visualization of difficult physics and computer science algorithms. And for example, the Huffman tree thing, this will actually give us intuitive insight into how the adaptive Huffman encoding works in a good bit. So I'm pretty excited to see how far we get. Yeah, pretty excited. Okay, so let's go here and let's go from there. Learning algorithms is fun to me. If I have a way of figuring quirks out, even the simple, I don't even know that one, sieve of Eratosthenes, I needed help with. So truth be told, for me, and this is just obviously for me, maybe for other people it's fine, I don't understand things until I understand them algorithmically. So a lot of times with physics, I end up running into a situation where like people will show me the math and I'm like, sure, I get the math. It's a Hamiltonian, I see where everything's coming from, but I don't get it until I go in and I actually write a code for it. And then I'm like, oh, I totally get it now. And I don't know why. It could be because the idea behind programming is closer to the idea behind experimental physics than it is theoretical physics, right? The idea is that you're running a numerical experiment, right? You set up all the parameters and you say, this should work. You run it, and if it doesn't work, you ask, why didn't it work? If it does work, you think, okay, well, I think I can get it, you know? It's for prime numbers. You create an array, add number 2 to it. Okay, I'll look into it. Feel free to keep talking about it in the chat. Okay, so what's going to happen if I run this? I'm not sure. No idea. Key.second. 325. Okay, what do we have here? Key.second, tree.bitmap. What am I doing? Find X position. Ah, we need this to be anim. And then let's go down here. There. Now let's do make. I don't know what I'm doing anymore. 17 watching. Oh, that's pretty cool. You start testing from 3 to n and add each prime to the array. Oh, that's pretty cool. Good. Okay, so Huffman visualization 112. What's the problem here? Draw tree. Wait. Am I reading everything incorrectly? Draw tree. Oh, wait a minute. Do I already have a draw tree command? Let me go over here. vi Huffman.h. Do I already have a draw tree? No, I do not. I wanted to use it for Project Euler problem 3, but the input is way too big for me. Oh, Project Euler is awesome. I've got a friend at OIST, the Okinawa Institute of Science and Technology where I work, and he loves teaching people things, you know? And we've been teaching a lot of programming, a lot of math and physics, and he loves Project Euler. It is fantastic. I'm still on the lookout for a simple enough factorization algorithm that's well suited for large numbers. I don't know very much about factorization, but it's something that I could totally look into. It seems like a good project to do kind of like maybe a couple days on for one of the YouTube videos that I'm going to be making soon. Okay, what do we need to do? Grow circle, draw tree. What's the problem here? In main, LD. If you guys have any, you know, if you guys know what's up, let me know. So we're going to do draw tree. Okay, what do we have here? Draw tree, frame anim, Huffman tree, tree. Okay, let's go down here. Anim, final tree. Looks to me like that should be fine. What's next? Let's go down to draw tree. Down here, frame anim Huffman tree. Oh, that would be the problem. I've been so scattered. I apologize for that, guys. Okay, what's the next? It says resolution X. Let's go to 324. So now every time we see resolution X, we need to change it with anim.resolution X. Oh, well, resolution Y. So let's do anim.resolution Y. Now let's make it one more time. And let's see what we got. Oh, there we go. We got something. So now we're going to do Mirage frames animation.gif. Good. Okay, so here are all of the external nodes being drawn. I don't think they're being drawn in the right position, but that's for another time. That's for another time. Let's see. Well, I got it working after seeing people just looping and dividing a bunch of times. There has to be an elegant way to solve the problem. Let's see. Mirroring. When you test it and check each element from the array, it divides the test number. Yeah, I should definitely look into that algorithm a little bit more. Okay. So what are we going to do? Well, we note that the Y position and the X position is both off by a good bit. So with this temp position Y, let's actually change this a little bit. Instead of multiplying it by the animation resolution Y, let's multiply it by this, and then we're going to drop it down a little bit. We're going to say this times 1.05 times the following. I'm sorry, 0.95. Okay, so this means we're going to shrink the total resolution by just a little bit. And then we need to add in something. So let's see. Well, maybe we don't. Let's add it in plus anim.resolution Y times 0.05. Sorry about that. Okay. Now, what's next? Find X position. Let's do the same thing over here. So it's not 0.5 times animation resolution X. X position plus, let me see. So we're going to have to add in half. So let's do this. X position times, what do I want? I want to do same thing I did before, 0.95 times animation, and then we're going to do plus 525. Let's see what happens if we write this, and then we make. Okay, seems like it did something. Let's do Mirage animation.gif. Oh, that didn't help. Let's drop this down a little bit more. So let's do 8.5 and 1.5. And let's do make. Oh, oops, I screwed that one up. This should be not 0.5. It should be plus 0.725. I think. Let's make. This should solve the problem, I think. I think I know what I did wrong last time. Yes, okay, so all of them are appearing. That's great. Let's change this back to what it was before because I realized I did something really stupid. So let's do 9.5. And let's change this to 0.05. Wait. 2.5. Make. And of course, if you guys have any questions about what I'm doing or anything like that, let me know and I will totally answer those questions as soon as I see them in chat. And this is not quite right. Dang it. Let's do 90. Okay, that's okay. 90 is fine. Let's go down here and let's do 92. And these will be changed later, and that's perfectly fine. 52555. Let's do make. And let me write a comment about that real quick, just so I remember later. Okay, good. So they're all being created. And these are all the external nodes. So these are all the leaves on the edge of the Huffman tree, right? Now we have to draw the internal nodes. Now, this is not right. I can tell you that right now. There's something wrong with the X positions here, but we're just going to draw it anyway. What language do you know I'm programming? RK4002. I believe you're asking which programming language I personally know. I use C++ all the time, and also CUDA recently. Let's see, I use Fortran a good bit. Python, Julia. I've used MATLAB, but I don't really like MATLAB. For the most part, this stream is C++ with a little bit of Julia. Every once in a while, we branch out, we do Fortran or Python or something like that, but it's usually C++. And most of the visualization, this is all C++. So I hope that answered your question. Guessed it so. Let me see. I missed a whole bunch of stuff in chat. I apologize for that. Don't do it by Steve. Okay. Guessed it so. Good. Good. Witty Bants. Wait. It's just personal preference, for the record. It's not like MATLAB is evil or anything like that. It's just, there's a lot of weird things MATLAB does, and because I don't use it very frequently, I'm not used to it. That's the truth. It's just, every once in a while, something weird happens. Okay, so, grow circle. We have the circles being created, and the coolest thing about this, guys, is because of the way we created the circles, they look amazing when they're appearing. Like, this looks great. I'm so happy with this. Okay. So let me leave a quick note in the determining the X and Y positions up here. I'm going to say, note the 0.9 and 0.05 are somewhat arbitrary and should be modified in final form. Okay, luckily this is not even the final form of the code, so we've got plenty of time to work on it. Okay, so what do we do? Temp position X, all the nodes are being created. Now we have to think about how we're going to do the internal nodes, and this is a little bit more complicated, unfortunately. So we know they're all going to add up, right? And let me see, how did I add these guys up together? We said we have a bit length, and the bit length determines their Y position. Then we say the number ones and zeros determine their X position, right? So if we have two words that are of the same length, then they should be on the same Y position. Something weird is happening here. I just realized. Okay, look, how many dots are appearing? 1, 2, 3, 4, 5, 6, 7, 8 are appearing. The tree we're reading in has way more than 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Okay, so let's see what's happening here. Why are we not having them all appear? It could be a number of reasons. I'm not sure why. So what I want to do is I want to actually output everything. So let's go here and let's do std cout. What do I want to see out? I want to see out the following: tree dot, oh, I'm sorry, key dot first. And then let's do a let's do an end line. Why not? Let's go here and let's make it. And let's see how many letters we go through. We go through what looks like all the characters. So it seems to me like everything is fine. J is 1, current radius is... Oh, oops. Let's go up to the grow circle command. What do we have? Let's not see out anything here. Let's go here and let's just press big ol' I and uncomment these guys. Okay, what's the next one right here? Period, and that should be good. For the record, guys, I am trying to get into the habit of letting you guys know when I do tricky VI or Vim stuff, and so if you have any questions on how I did anything via the text editor, let me know and I'll totally answer those as soon as I see them. Okay, finished loop should also not be there. Where's finished loop? What? 1 second. Let me just look for finished loop. Here it is. Let's go ahead and press big ol' I and comment this out. Okay, so big I in VI goes to the very start of the line, right? And then it also inserts at the start of the line. So I basically pressed big I, went to the start of the line, put in my comment. Okay, so we are clearly going through all the characters, which is absolutely fantastic. Now let me see. How many of these guys are we going through? 1, 2, 3, 4, 5, 6, 7, 8. Huh. What are all these guys? 31, 34, 37, 40, 43, 46. I'm actually not sure what's happening here. Okay, so let's see. We have current radius is 6. What is this? What are we outputting? 4, 7, 10, 13. What is this? SDC out. That's commented out, and it has to come before that. Okay, let's go down to the, where are we? Draw circles command. So let's go down here. Key dot first, we're outputting that, that's fine. And then we go to the grow circle command. It has to be within the grow circle command. So let's go to grow circle. Okay, so there should be a C out somewhere in here. So let's go to C out. Okay. It finishes the loop, then it outputs something. What does it output? Animation.current frame. Ah, I see. I see. That's it. I get it now. I totally get it now. Okay. So we ran into a situation where we have too few frames for the number of points that we have to draw. So let's go up to the top and let's kind of look at this real quick. So let's go down here. Let's see. So we have grow circle, and we say it has 10 total seconds divided by double of external nodes dot size. Let's see. Is that correct? 10 seconds, 30 frames, 10 frames a second. Yes, so that's the problem. I give it 10 seconds when I should have given it 3 seconds. So let's see what happens if we give it 3 seconds. Write this, go over here, make it one more time, and let's see what happens. It's probably going to break, but that's okay. We're used to broken code. Mirage frames animation.gif. Whoa, look at that. Okay, so this has way more, and that's good. But is this the right number? Let's see if we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 total. Okay, there seems to be 13 leaves. How many should we have? We should have, where are we? Ends at W. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Huh. Okay. Well, we should have 24. So let's go out here and let's output one more thing real quick. We're going to output the following. std cout. What do I want? I want to see out. Where are we? What am I doing? Bitmap? Yeah, let's do tree.bitmap.size. And let's also output, what do I want? I want to do external nodes.size. Okay, and I've got a tab in the middle there, so let's go ahead and add in an end line and a tab in the middle. Good. Let's write this, go over here, and let's make. What do I do? SDC out, tree, bitmap size. Of course, I forgot parentheses. How could I be so blind? Make. Okay, let's see what we got. It looks like we're outputting 27 and 27. So there are 27, which is close to what I think I wrote counted 24. I don't remember. 2, 3, 4, 5, 6. Oh, it actually looks like they may have all made. Right here. No, we're clearly. Maybe some of them are being recreated. No, it looks like they're all being created for the first time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The max size is 7. Wait, let's just leave that up for a second. The max size is 7. Okay, this is taking a lot longer than I thought it would, guys. I apologize. I was not expecting to run into these issues. Let me see. So the radius is 10. That should be fine. The total time is 3 seconds. What if we drop this to 2.5 seconds? How about 2.7 seconds? Oh, no, better yet. Let's increase the time to 10. And then let's go up to the top. And let's change this to 100 frames. Now let's go over here and let's make it one more time. Oh, make. Give it a second to do the thing. In the meantime, this is Steve. Open link. Wait, did you just write this? Pastebin.com? I'll have to look into that. Okay, so let's go here and let's do animation.gif. it looks like it is creating the same exact points. So let's change this up a little bit. Let's go down to the bottom. Is there any point? Oh, okay. Is there any point in which the Y position could be negative? Let me see. Key second size divided by max bit. So this should give us a number between 0 and 1. Why are they not all appearing? It looks like we're only appearing, or only a few of them are appearing. Let me see. So let's take a look at what we have here. It looks like we should be drawing one at the following points. So 4, 7, 20, 10. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 3, 4, 5, 6, 7. Okay, so we have all 27. That's fine. What's a Huffman Forest? It's a bunch of Huffman trees. I didn't know what else to call it. But yeah, we're totally going to be drawing a whole bunch of Huffman trees if I can get this working, which it looks like I might not be able to. But that's okay. We'll see how far we get. Okay, so let's see. What is the issue here? The issue here is that we're not drawing all the points, and we need to draw all the points. But it says we're drawing all the points. So let's go through and output the X and Y positions of all the points. So where are we? We are grow circle, and let's just output them all. So we have temp position X, temp position Y. So as we're creating these positions, let's go here and say std. We already have one. Let's go here and do tab. And then we want, what do we want? We want temp position. Yeah, temp position.x, tab, and then temp position.y. And line. Yeah, so each tree represents compressed data. The idea, how do I put this? The Huffman tree is a way in which you can encode a, here, let's just do it this way. I'm gonna go here. I'm going to make, oh, right here. Now I'm gonna make over here. Okay, so what we've done, let me go up here. We put a phrase in. Jack and Jill went up the hill to fetch a pail of water. Jack fell down, broke his crown, Jill came tumbling after. Oh, I should have looked at that. Thanks, Marion. Then the encoded phrase is this. We're interested in drawing the Huffman tree because in a bit we're going to have to do the more complicated dynamic Huffman stuff, which is not going to be the easiest thing to do. So we want something that's visually appealing and visually understandable so that when we go through, we can, how do I put this? So that when we go through, we can understand how the dynamic Huffman tree is changing. For now, we just want to draw a simple tree, and I'm failing miserably at that, so we'll see how far we get. But anyway, what we do is we basically create a map of all the characters, we encode it, and then we decode it. So decoded phrase is this, encoded phrase is this, and we're interested in looking at what the tree, looking at how the tree looks like, in a way. And again, this will be up on my YouTube channel, probably in 2 weeks. So today I'm putting up a video about the Monte Carlo stuff. In 2 weeks, we're going to be putting up a video about the Huffman stuff, hopefully, if we can get everything done. And then hopefully 2 weeks from then, we'll be putting stuff up on the dynamic Huffman encoding, crossing my fingers if we can get it done. I think we should be able to. Okay, so here's a bit of a problem. The X position of some of these guys, for example, this I, is... No, that's not a problem at all. The resolution is 400 by 300, 400 in X, 300 in Y. Now this T is 477, which is clearly not right. This one's 425, but the rest of them seem to be fine. Now I don't know how this guy got to 477. Yeah, I don't know how that guy got to 477. Not sure. So I guess we'll fix that guy, since we can. Let's go down here. Okay, so if X position is going to be whatever it is currently, X position equals 0, we're going to say X position, if we have a 0... Oh, wait a minute, let me think here. So we add 1. Okay, wait, let me think. We divide by max number of bits. The max number of bits is 7, right? Oh, they should be okay. So let's say X position is, I see. Let's go here and change it from X position to X position times 2. So let's multiply. Yeah, let's do it. It's gonna be 2 times this guy. Let's remove some spaces just because I want to remove some spaces. And we'll see what happens. Okay, let's write this, go over here and let's make. Okay, now let's see what happens if we take a look at the animation. We should see a few more dots. Not so many more dots, but a few more. Okay, we see a couple more. Let's see, how many do we see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Still not the number we need. Okay. So let me see. What is the issue now? The issue... I don't know. I don't know what the issue is. I have no idea. So let's try changing the Y position too. So let's... I don't think so. Because they each have a different X and Y position. So let's go up here. So you can clearly see that they have a different X and Y position here. So let's say the space is going to be 168.92. The next is going to be 168, which is the same X position, but its Y position is different as 169. The next is going to be at 207, 207, so the same Y position, but the X position has changed. Let me see, 220, 169. Actually, you know what? It looks like there are a couple that are overwritten. Yeah. Let me see something. 285, 194, 297. Yeah, a lot of these guys overwrite themselves. That's totally fair enough. Okay, I get it then. The problem is we are not doing this correctly. So it must be the X position that's incorrect. Because the Y position, I think, should still be determined by the length at which we're at. So let me think here. For the X position, let's see if we can find a better way to determine the X positions. So let's do page, new page before. Here's what we currently got. We've got a situation where we have a root node up here. We'll call it R. Why not? Okay, and then we have a whole bunch of other nodes down here somewhere. The idea is that this Y position is determined by the length of our bit string, which should be right? So it should be that the further away we get, the longer the encoding is, right? That seems intuitive and makes sense to me. Now the question is the X positions. So if we go 1, 0, then we go 1, 0, 1, 0. Ah, I see what I did wrong. Yeah, I was totally wrong here. Okay. So we've got to think of a better way to parse this. Because what I was doing was just adding all the 1s and 0s together. But you could have a situation where you have maybe 1, 0, 0, 1. Okay, so 1, 1, 0 is going to add up to positive 2. So let's draw this route. 1, 1, 0 is positive 2. But 0, 1, 1 is also positive 2. So you're totally right, Marion. They are overwriting themselves. Now we have to think of a way to do this. So let's go through and let's think about this. So all we need to do is split this guy up into boxes, right? The idea is that we go through each individual element and we say if the first element is 1, we're over here. If the second element is 1, we go over here. If the third element is 0, we go over here. Positive 2 VAT. Yeah. Okay, so now let's think. Why are you saying... I thought it would make sense at the time. I was clearly incorrect. Okay, so now how are we going to do it this time? Let's see. Okay, well, this, I guess, should make a good bit of sense to do it another way. So we know... Let's see. I apologize, Linkadoo. Okay, so we know this. This has 2, this has 4, this has 8. The next is going to be 16, so on and so forth. So at position 1, we'll give it 2 different positions, okay? So if we have a string length of 1, then it's going to either be here or here. Where they are, that's inconsequential. Point is, it's either here or here. Now we have a next situation where we're at 4, right? So we're already at this position here and that position here. Then we ask ourselves, okay, well, do we have a 1 or do we have a 0? If we have a 1, we then subtract out some position here. If we have a 0, we add in some position, so on and so forth. So what we need to do, so it's 2 raised to the position. Yes, that's exactly what it is. So what we need to do is the following. We need to say at node. Okay, we're at node. Then we say, so the first guy. We go through the entire length and we say if the first guy, the first person, I suppose. Wait, I have to think about this. This isn't so easy. I have an idea. What we're going to do is we're going to say if we're at the node, we're at position 0.5. We're right at the center, right in the middle of the resolution. Then what we say is, okay, we're at position 0.5, which is a resolution divided by 2. Then we say, okay, if we get a 1, we then divide by, or rather, we subtract out resolution dot x divided by 4, which is going to be the next guy here. Okay? If 0, we're going to do position, let me think, plus equals resolution x divided by 4. Okay? And this means that we're at position either negative 2.5 or position 2.5 or 7.5. I think this is right. Okay, let's try it. Okay, this is going to be really rough. But we'll see what happens. We'll see what happens. Okay. So, if this works, it's probably going to be the end of the day. If it doesn't work, it's probably going to be the end of the day. So I apologize if it's a little, well, okay, that's fine. So let's go ahead and give these guys an initial X position. And that X position is going to be animation.resolution X divided by 2.0. That was a 3. 2.0. That's the initial X position. Quantum joke. Okay, now size t, I equals 0. I less than bitstring.size, I plus plus. We go through each of them and we say if bitstring I is equal to 0, then we say x position is not x position minus 1. Instead, it's going to be x position minus resolution anim.resolution x divided by I plus 1. Let's do double of I. Plus 1.0. Okay. And then if it's a 1, oh, this should actually be subtracting out. 1 second. Plus equals. And this is going to be minus equals. Okay. So then we should say animation resolution x double y plus 1. Yes, I think this is right. So then we're going to do animation resolution x. Divided by. I guess it's the same guy we had before, right? So let's just grab this guy. What's the worst that could happen? Here. Okay, X position is going to be, yep, that's fine. We'll scale it later. Right here, let's make it. It's gonna break. Knew it was gonna break. But not for the reason I thought it was gonna break. Double of I. We need an extra, or rather one less parentheses. Now let's do make. Okay, let's see what happens. It looks like we have positions. Let's see what happens if we look at the animation. I think this is clearly, yep. Okay, that's what I thought was going to happen. We have more points, but we're missing half the points. And that's because we need to scale it. Okay, So what are the X positions that we have so far? We have all of these positions here. We have one that is in X position 800, which is weird to me. I don't how did we get to 800? I'm not sure. That one, we had a single one. Wait, what? Go to the space. The space is 0, 0. So what did we do for that one? We went to 0. We said, hey, we found a 0. Then we went through. And we said we're going to add in double of I, animation resolution.x, divide by double of I. So we were at position 200, because animation resolution.x is 400. So we were at position 200. And then we said it's going to be whatever it was before, 200, plus, it should just be 100. Oh, shoot. I did this wrong. It should be 2, 4, 8. Is it power of 2? Let's do divided by power of 2, and then double of that. And let's do this down here. Oh, that was meant to be a W. I think this should be right. Power. I did the same thing again, 2. And let's see what happens there. Now we're going to make. It's probably going to break. Or not. I don't know. Oh. I need to get rid of the animation. Okay. Let's see. 500's a little bit better. Okay, let me see. You need a value to know what level you're at. Yeah, so that should be I, right? So I is going to be 0, I is going to be 1, I is going to be 2, so on and so forth. We're clearly getting more points. That's fine. That's actually good. We're getting more points. But we're not there yet. Okay, let's see. What do we have here? We have these positions. 500. And then the rest of them look good, except for this top one. The rest of them look like they actually might be reasonable values. I mean, you know, with exceptions. So let's go here and say, oop. Then at the end, we're going to say X position. Oh, no. Let's do it here. We're going to say X position plus equals animation.resolution. Let me see. From what I get, it's the index for the bit string. Yes. And that's exactly what we've got. So we're going through each of these guys. So we start with the node with nothing. And then we say, okay, this is at position 2.0, right? And then we say, oh, you're right. Let me think. So if we're already at halfway, okay, that means we're at 1. But this is going to say, yeah, let's add 2 instead of adding 1. And let's make that. Okay, let's see what we got. We have everything on the board. Let's see what happens. Let's do Mirage animation.gif. Yeah. I think that's 27 points, guys. We have all 27 points on the board. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can't count. Let's go through and do this another way. So what we're going to do is we're going to go to Mirage, Frames, Image, 0, 0. Okay. Let's go through to the very bottom. Frame 99, and let's count. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. How many should we have? I thought we said we needed 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, there's 3 there. Okay, so that's 25. There's probably... Okay, so we got 25. 1, 2, 3, 4... 1, 2, 3, 4, 5, 6... 7, 8, 9... 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 26, 27. Oh, we have 27. Yeah. Let's count it again. 1 second. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Bam! Got it. Yeah. Fantastic. Okay, so they're all there. Now we have to scale it so it fits the appropriate box, but I'm happy with that. We have all of the external nodes being drawn. The internal nodes are going to be a little bit difficult, but I'm going to spend some time today working on that. So I have to kind of think it through how I'm going to do it. And so hopefully tomorrow when we get in, we can just do the visualization without so much trouble. Okay, so now let's look at the animation one more time, and let's see what we need. So clearly we are animating all the points. However, there's one thing that I don't like about this, and that's that this point over here is off the screen. So we need to shrink everything just slightly. Okay, so what we're gonna do is, let's see. We are going to subtract out, yeah, we're gonna do this. And this is gonna look really weird. So we're going to say x position is going to be equal to x position minus animation dot resolution x times 0.5 animation dot resolution x. Then what we're going to say is the following: not to random in range of radius. You tell them not to random? Okay, so we're going to say x position, let me see. Then we're going to multiply this times, again, 0.95, we'll say. Okay, and then after that, we're going to add in plus, what do I want? Animation.resolution x, and we want to multiply this by 0.5. Let's go over here, X, and let's do make. Okay, now we're going to very quickly run the animation, and I think this should be fine. Yep, so all of them are on the board. And again, I have the note up here, the 0.90 and 0.95 are somewhat arbitrary. Okay, so let me see if I got this temp position Y right. We have double key.size divided by double max bit, then we multiply it by 0.9. Okay, so we shrink it down a little bit. Then what do we say? We say, yep. Then we add in animation resolution Y times 0.05. I think this should work too. Yeah, I think that temp position Y should work. Okay, looks good to me. So let's go ahead and right quit. Let's do git commit Huffman visualization.cpp. And we're going to say added in visualization of external nodes. Oh, shoot. I forgot something. I think we changed the make file. Oh, we changed a lot of stuff. We changed Huffman.h. What did I do with Huffman.h? Let's do git diff Huffman.h. Looks like I removed a line. Fine. Okay. What else did I do? Let me do git diff. The make file. I think I added... Oh, that was an it. I think I added... Yeah, so I added a second object. Good. So let's go here. Let's do git add the following. We want the make file. We want Huffman .h or .cpp and Huffman.h and then Huffman visualization .cpp. Git commit. Again, I apologize for how messy this is, but we're going to say added in visualization of external nodes. Internal nodes coming soon. git push origin master. Okay, so we didn't get as much done today as I would have liked, but we went through a good bit of stuff. Let me think. Shouldn't it place points from top to bottom? I think it is. Let me think. I'll look into that in just a second. So this is available. Just go to my stream. Here's my stream way up here. Scroll down to the very bottom here. Click on my GitHub link, which is right here, or anywhere down there. Simuleos, and here's the latest changes right here. So these are what we've done so far today, and Marion just brought up a good point. I think we're drawing things backwards. So let's go here to VI Huffman visualization. Oop, that wasn't what I wanted. .cpp, and let's go down to the bottom. Okay, so now the Y positions. The way Cairo counts is it's 0 up top, 2000 at the bottom. Okay, so that means, what are we doing? We're saying if the size is incredibly small, let's say the size is 1 or 2, then we divide it by the max number of bits, then it should be way up here at the top. I actually think this is right. I think. So let me go through and let's see. So it says, let's go here. It says here that this space is at position 92, which is as high as it can be. Then we have, let's see, which is one that has a lot of characters. Let's say the T, capital T, is at position 285, which is relatively low. Yeah, almost, I think it's as low as you can be. So I think this is actually drawing them in the correct order, because 92 is very high, 285 is very low. So I think it is drawing them in the right order. I just think it's a little bit weird because of how Cairo does the drawing. So let's go here to Mirage. Okay, it looks like we have everything ready to go. Let's go ahead and outline the next problem, which is going to be the internal nodes. The internal nodes are not going to be incredibly easy to draw, even though we have everything connected. And this is actually kind of the reason why I wanted to start with a more complicated case and work into an easier case, because it would be so easy for me to create simple cases of this. But I have to make it extendable to a large number of external nodes. So let's go here and let's talk about this. Page, new page before. Okay, so at this point we can draw a whole bunch of external nodes, right? So we'll just kind of say, hey, they're green and they're all the way over here. Somewhere here are all of our external nodes. Okay. Now, what we need to do with the Huffman algorithm is add in all of the smallest nodes first. So all of these nodes that are appearing down here will all need to be added together, and then we need to create a whole bunch of internal nodes and stuff like that. Each internal node has a weight, and that's great because this means that we know where to put the internal node, right? It's based on how many points are within the node. So for example, if we combine these two nodes together here, the weight will be the new, I guess you could say, length of the string. And it will be equal to this length, L1 plus L2. Okay, so we can find a position of each of the internal nodes. The problem is this. We saved all of the nodes in this big thing, which is a node star. The node has basically two children. So it has left and it has right. Okay? So we start with the basic node at the very top. And then we kind of build ourselves down. So we can have some sort of initial position to start with, which is, you know, how do I put this? The root node. Then we go through and say this is connected here and here, okay? So what we need to do then is continually transverse the root node until we find a character, until we find one of the end nodes. And then we say, okay, well, this node is connected to the following two nodes, so on and so forth. The problem is, I don't know, did I save the parent with the node? Let me see, if I save the parent, this will be a lot easier. I think. We'll see. I think I saved the parent. Let's go here and let's do, remove that. And let me go into Huffman.cpp. Okay, so let me see. Did I do parent? Parent. It looks like I did save the parent node, which is good. So since I did save the parent node, all we need to do is find the character nodes, right? And then once we find a character node of the lowest weight, we then need to go through and basically at that point, let's see. How do I do this? At that point, we basically need to recreate the Huffman diagram. And that actually isn't so bad because we already have done that before. So we just initialize them all of the appropriate weight. And then after initializing them all of the appropriate weight, we just go through and we just add up the two of the smallest weight continually. So we just basically have to redo this, one of these functions over here. It's just do it visually this time. So create nodes. Let me see, vector of characters. That's not what I want. Create nodes. Let me see. Node Q. Yeah, so what we need to do is basically, let me see, initial nodes. I'm not seeing it. But we have a way, we've already done this before, in which to create the Huffman tree. So I think we should do the same thing here. Okay, so now I think I see what we need to do. I'm pretty sure I see where we need to go. It's just a matter of actually doing the code. And I apologize for being so vague today. At this point, even though it is a few minutes early, I think we're going to go ahead and wrap up today's stream. We got a good bit done. We did the external nodes. I would have liked to have done the internal nodes too, but that's going to take some thought on my part. And since we've already drawn the Huffman tree by using this node star thing, I think we're going to use a very similar function to do things with the actual drawing. And then we're just going to draw them in the appropriate locations and hope that it looks okay. That's about all I've got. We do have a bit of a problem in that when we draw the lines, they're going to go over these nodes that we've drawn. And that's something that we're going to have to get to when we get to it. I guess we'll have to see, hey, is a line interacting with, or is a line going over one of these points? And if it is going over one of these points, we're going to have to redraw that point, or something to that effect. I haven't quite figured out how I want to do it exactly, but that's something to hit when we hit it. At this point, guys, I'd like to thank you guys so much for watching. We've got, let's see, a good bit of stuff that's going on today, so I'm finishing up, or rather, I just finished up my video as of last night. It's uploaded to YouTube. I need to put it out in an hour or two, but I want to make a blog post about integrating the bat symbol first, because I thought that turned out really well. If you're interested, I will give you guys a link tomorrow as to the actual video and stuff like that. I'm pretty excited with how it turned out. I think it turned out, you know, decent. Again, not as visually appealing as the eigenvector video, but that's okay. Anyway, guys, have a great day, night, afternoon, morning, evening, whatever time it happens to be your time, and I will see you around next time for the next episode of Simuleos, where we continue working on this, draw all of the internal nodes, and get ourselves an actual Huffman tree. Again, we can make the tree look as pretty as we want after that point, but let's just get the basic tree down and go from there. Thanks for watching, and I guess I'll see you next time. Bye, guys. Oh yeah, and have a fantastic weekend.